Just imagine our planet suddenly turning immobile one day. What are the possible havocs? It's sure that at some boring point in life, you might have had the weirdest imagination of such a Hollywood daydream. But have you ever been curious enough to wonder about the actual scenario? Of course, that would be hard. But to what extent? On Earth, a single day would span a year, with half of the world in darkness for 6 months and the other half bathed in sunshine. It may make a spectacular weeks-long sunset, but that's just us looking for a light at the end of the tunnel in what would otherwise be a pretty terrible situation. Thank you for visiting our YouTube channel. Subscribe and hit a like before it's too late and the Earth stops. With a revolving speed of 1,000 miles per hour at the equator, a sudden pause would put all life on Earth to a screeching halt. A dramatic representation of such a phenomenon taking the bridge of visual arts would make it a really expensive project. It would be like making another movie of Titanic in contemporary times. Just wondering. All water on the dark side of the planet would freeze as temperatures decreased. Oceans would be evaporating on the sunny side of the Earth as temperatures approached 212 degrees Fahrenheit, 100 degrees Celsius. There could still be hope for life on Earth if it came to a very slow, gradual stop, especially towards the equator. As water is driven towards both poles, any living species that still can move will be able to follow the line of the equator around the whole circumference of the world. Supercontinents would arise as land masses collided, but no one would be present to judge how great they were at the time. The Earth's rotating speed is at its fastest at the equator, at roughly 1,000 miles per hour. If that motion came to a halt, the momentum would propel objects eastward. Earthquakes and tsunamis would be triggered by moving rocks and oceans. Landscapes would be scored by the still-moving atmosphere. But don't worry, such an event would necessitate the same amount of energy stored in the momentum of everything on our rotating planet, which no physical mechanism on Earth can provide. At least once in your life would you have encountered the term inertia. And what is it? Every day, the Earth rotates on its axis, completing a full rotation. Why does it behave in this manner? The assumption that constant motion necessitates a constant force is one of the most widespread physics misunderstandings. Many people think that the Earth is kept rotating by some force reality. No force is needed since mass has the characteristics of maintaining its state of motion in the absence of external forces. Inertia is the term for this feature. Since its creation 4.5 billion years ago, the Earth has been rotating. The Sun rose from the collapse of a massive cloud of stuff, and the Earth was constructed from the rubble that was left over. The slag that became the Earth spun around the Sun like water around a plug hole when you drain a bathtub. After it was formed, the Earth continued to orbit the Sun and spin, and it will continue to do so for a long time. The Earth rotates at a constant rate of once every 23 hours and 56 minutes. During this period, the Earth advances a little further along its one-year orbit around the Sun. This means it must turn a little more for 4 minutes until it is back in line with the Sun. This translates to a 24-hour day on Earth, moving across space. Because there isn't much that can stop the Earth from spinning, it continues to do so. If you spin a playground roundabout and then let go, it will ultimately come to a halt. This is because the air and the playground surface are pressing against it as spins, producing friction and slowing it down. The Earth spins across space, which is mostly empty. There is no air in space to press against and impede the Earth's rotation. The Moon, on the other hand, slows down the Earth's rotation. Gravity does not fully balance the motion of the side of the Earth facing the Moon, nor does it balance the motion of the side of the Earth facing away from the Moon. The ocean tides are caused by this imbalance, which causes the oceans to bulge out on either side of the Earth. The Moon rises above the ocean. The Earth's rotation is affected by the Moon. Shutterstock. Ivan Sorokin. These bulges sweep over the Earth's surface like a wave as the Earth spins, pushing against the Earth's spin. The Earth's rotation is slowed as a result of this. Every 50,000 years, the Earth's day lengthens by 1 second. The only way to stop the Earth's rotation is for another planet to collide with it. Even if this occurred, it is more likely that the Earth's rotation would be altered rather than completely stopped. And you get a day that lasts 6 months. You wouldn't be blasted into space if the Earth abruptly stopped rotating. You would still be securely planted on the ground, thanks to gravity. However, there would be several adjustments. A day would last half a year, and a night would last half a year if Earth stopped spinning, but continued to circle the Sun. It might warm up significantly throughout the day and cool down significantly at night. This would have an impact on the Earth's climate. Strong winds would be caused by a substantial temperature differential between day and night, which would pull warm air towards the colder nighttime side of the Earth. The wind would also blow from the balmy equatorial areas to the frigid Arctic regions. This does not happen on a spinning Earth because the wind is deflected sideways. The winds from the east and west, as well as the winds from the poles, would collide. They have the potential to generate massive wind swirls the size of continents. Part of the Earth's core is molten iron. The Earth's rotating speed converts this molten iron into a magnet, creating a magnetic field. This shields us from damaging radiation emitted by the Sun's particles and cosmic rays from beyond the solar system. The magnetic field prevents the radiation from reaching us, but it does reach the Earth's atmosphere, where it is visible. This radiation would reach the Earth's surface if it weren't for the magnetic field, making humans sick. Because certain birds rely on the magnetic field to navigate, they would become disoriented if the Earth stopped rotating. Because you would constantly be staring out into space in the same direction, if the Earth didn't rotate, the night sky would always show the same constellations of stars. Viewing the stars rise and set over the night, as well as seeing various constellations at different seasons of the year, is a distinct experience. We take for granted so many things: our health, our next breath, and even the charm of life on Earth. If everything on our planet suddenly stopped moving, it may signal the end of life as we know it. The Earth rotates once a day on its axis, making sunrises and sunsets a regular occurrence on the globe. It has done so since its formation 4.6 billion years ago, and it will do so until the world ends. Most likely, when the Sun expands into a red giant star and absorbs the planet. But why does it rotate in the first place? A disk of gas and dust whirled around the newborn Sun, forming the Earth. According to Space.com, a sister site of Live Science, pieces of dust and rock stuck together to form the Earth in this rotating disk. Space pebbles continued to collide with the young planet as it developed, generating pressures that spun it, according to some scientists. Because all of the debris in the early solar system rotated in the same direction around the Sun, the impact spun the Earth and much of the rest of the solar system in the same way. But in the first place, why was the solar system spinning? When a cloud of dust and gas fell under its weight, the Sun and the solar system were born. The majority of the gas condensed to become the Sun, while the rest went into the planet-forming disk around it. The gas molecules and dust particles were moving all over the place before it collapsed, but at the same point, some gas and dust shifted a little more in one direction, causing it to spin. When the gas cloud contracted, the cloud's rotation accelerated, similar to how figure skaters spin faster when their arms and legs are tucked in. Because there isn't much in space to slow things down, once anything begins to rotate, it typically continues to rotate. In this situation, the revolving newborn solar system possessed a lot of angular momentum, which is a statistic that defines an object's inclination to keep spinning. As a result, When the solar system began, all of the planets most likely rotated in the same direction. Scientists are unsure how these planets came to be in the state, but they do have some theories. Venus's rotation may have flipped due to a collision, or it might have started spinning like the other planets. The spin of Venus flipped over time when the Sun's gravitational pull on the planet's heavy clouds interacted with friction between the planet's core and mantle. Venus's rotation may have slowed and reversed due to gravitational interactions with the Sun and other variables, according to research published in Nature in 2001. Regardless of such perturbations, everything in space rotates in one of two directions. In the cosmos, rotating is a basic characteristic of things. Asteroids move about in space. The stars move about. Galaxies move around in space. It takes 230 million years for the solar system to complete one circuit around the Milky Way, according to NASA. Pulsars, dense, spinning objects that are the remains of huge stars, are some of the fastest things in the universe. Pulsars may spin hundreds of times per second and have a diameter of approximately the size of a metropolis. Things do, however, slow down. The Sun rotated once every 4 days when it was created. When we go by certain theories today, though, it takes around 25 days for the Sun to rotate once. Its magnetic field interacts with the solar wind to delay its spin. Even the Earth's rotation slows down. The Moon's gravity pulls on Earth in such a way that it somewhat slows it down. Our planet is known to have a variety of solar system motions. The movement of the Earth's rotation is one of the most significant, as it is the one that causes day and night. The rotational movement of the Earth is the movement of our globe in an east-west direction around the Earth's axis, which takes around 1 day or 23 hours, 56 minutes, and 35 seconds. This movement, together with the Earth's rotation around the Sun, is the most significant on the planet. The rotating movement, in particular, has a significant influence on the daily lives of living organisms. The formation of the solar system explains why the Earth spins on its axis. It's likely that when gravity allowed it to emerge from amorphous materials in space, the Sun spent a lot of time alone. When the Sun was created, the clouds of primordial material endowed it with rotation. Precession. It is the Earth's slow and steady change in the direction of its axis of rotation. The movement of force exerted by the Earth-Sun system causes this motion, which is known as the precession of the Earth. The tilt with which the Sun's rays reach the Earth's surface is directly affected by this movement. The current inclination of this axis is 23-43 degrees. This indicates that the Earth's rotation axis does not constantly point to the same star, polar, but rather rotates clockwise, causing the Earth to move in a top-like motion. On a human scale, a complete revolution of the precession axis takes around 25,700 years, therefore, it is significant. If, on the other, we measure it in geological time, we can understand how important it is during glacial periods. Translation. Then we'll look at the Earth's second most complicated movement. It is the Earth's movement, which consists of it turning in its orbit around the Sun. This orbit has an elliptical movement that brings it closer to the Sun at times and farther away at other times. A full rotation of the Earth on its axis of translation takes 365 days, 5 hours, 48 minutes, and 45 seconds. As a result, every 4 years we get a leap year with 1 extra day in February. This is done to change the timetables and keep them consistent. What if the spinning comes to an abrupt halt? First and foremost, rest assured that this will not occur, at least not in the next few billion years. But just for the sake of speculation, what if? Needless to say, the consequences of such a rare occurrence occurring so suddenly would be nothing short of destruction. According to NASA, if the Earth's rotation came to a halt, anything that wasn't securely fastened to the bedrock would be displaced. The reason for this is that even if the Earth's rotation were to cease, the atmosphere would continue to move at its original speed of 1,100 miles per hour or 1,770 kilometers per hour. As a result, everything that isn't securely tied to the bedrock will be carried away, including massive rocks, topsoil, and structures. Another aspect of the global crisis is that it is a little less spectacular. What if the Earth's capacity to spin was lost gradually rather than suddenly? Assuming that the ecosystem's various components remain intact, the consequences would be quite different from what would have occurred if it simply stopped. How would you resolve to hypothesize the sudden pause of the planet all of a sudden? Make sure to let us know through the comment box. Hope you had fun watching the video. Bye-bye for now.